Okay, so so we're talking about square root functions here. And like the name suggests, a square root function is a function that contains the square root of a variable. Okay, so it's root x. The parent function is f of x equal to root x. All right, let's use a table to graph the very first one, right? Just the parent function, f of x equals root x. So here I have x, and here I have f of x is equal to root x. All right, so I'm going to pick values for x in order to plot them, okay? Now, I've always said that when you want to pick values for x, you have to do it wisely. So you have to get some positive ones, you have to get some negative ones, and you have to get the 0. All right, now, let's take a look at this function specifically. Can I put in any negative values for x? No. What's the first number on the x-axis that I could put in?
1.
Can I put in a 0?
Yeah.
Yes, I can put in a 0. Because when x is 0, the square root of 0 is what? 0. Now, can I put in a 1?
Yeah.
Because the square root of 1 is 1. Now, I can go on. I can put in a 2, but the square root of 2 is not a rational number, so let's skip it. So what's the next perfect square that I could put in? 4. And it's the square root of 4, which is 2, right? So let's graph this one. At 0, we're at 0. At 1, y is 1. When x is 4, it's 2. And I could probably go one more, right? What's the next number I could put in? A 9, and I would get a 3. And you see that that's what the square root graph looks like. Okay? So you have to be mindful of the fact that your domain is limited, right? Because you can only have a graph over the x's, which will not give you a negative in the square root. So you're fine as long as the x value does not give you a negative in the square root. Okay? Right, just like that. Okay? All right. So, moving on here, let's graph a couple here. Right? So we've got a whole bunch here. Now, let's just explore a little bit more here, right? So we can pick points always, or we could graph these like we would graph parabolas, right? So from the first point here, from the initial point, 0, 0, if I go over 1, how much do I go up? 1. And then what's the next step? I would have to go over 4 to go up 2, and then I would have to go over 9 to go up 3, right? And you could always do that. I'm doing this one. Okay. And you can always do that. As long as there is no vertical or horizontal dilation, you could always imagine, okay, I can go over, a number that's a perfect square. I can go over 4, and I have to go up the square root of 4. I go over 9, and I have to go up the square root of 9. You could go over 5 and go up the square root of 5, but who wants to do that, right? Okay, so you see how, like with the parabola, we would go over 1 and then go up the square of 1. We would go over 2 and go up the square of 2, 4. Now we're going up the square root, so much, much slower. Okay. Huh? Right, the inverse. So here, right, look at the x minus 2. What does that minus 2 do to the graph? It moves it somewhere. Where does it move it? To the right 2. So we're going to be here, to the right 2. And now there is no horizontal or vertical dilation. The function is not multiplied by any other constant. So I could do the same thing. If I go over 1, how much do I go up? The square root of 1, 1. If I go over 4, 1, 2, 3, 4, how much do I go up? The square root, 2. If I go over 9, I go up the square root 3, which I don't have enough room here. So it's going to look like that. Okay? You could have also picked points, right? So here, my first point is at 2. I could have also picked points, but what I do is I pick points for x so that when I put it inside the square root and do x minus 2, I'm going to end up with a perfect square, right? So for example, what would I pick? 11 would work. 3 would work. So I could put x equals 3 because 3 minus 2 would be 1, and I could take the square root. I could do 6 because when x is 6, 6 minus 2 is 4, and I could take the square root, right? Okay. So let's do the next one. Where is my graph going to move for part? Oh, wait a minute. Let's do domain and range. Sorry.
You would still have to start 2 to the right if you do the subtraction.
Right. Okay, so domain and range for this one. What's the domain? Greater than or equal to 2. So x is greater than or equal to 2, and y greater than or equal to 0. All right? Could we have figured that out from the equation? We know that this is, it's a basic square root, so it's always going to move towards the right. It's going to start at 2, always move to the right. It hasn't moved vertically, so it's going to go from 0 up. Okay, so look at that one. Before I graph that one, let's try to do domain and range. Let's do domain. Where has this thing moved? To the right 4, and it's going to keep going further to the right. So what's the domain going to be? X is greater than or equal to 4. And what's the range going to be? Y is greater than or equal to 3. Okay? So this is telling me that I've moved to the right 4 and up 3. To the right 4 and 1, 2, 3. And now, same situation. If I go over to the right 1 unit, how much am I going to go up? 1 unit. If I go over 4, how much am I going to go up? 2. And man, if you do it this way, you will be so successful in your pre-calc, in your calculus, right? Okay. In life in general, absolutely. Okay, so let's take a look at this one now. What changes do we see here? Vertical dilation, right? Okay, so what is the negative 5 going to do? Move it to the right 5, so I'm going to start here. So now, if I go over 1, I would have normally gone up 1, but how much do I go up now? 1 times 3. If I went over 4, I would have normally gone up 2, but now I go up 6. So 1, 2, 3, 4. At 9, we're gonna be up at 6. So you see how much wider? Okay, it goes that way. Yeah. Oh, no. Yeah. You don't have to. Okay. So take a look at this one. The plus 4 does what to it? Left 6. The minus 6? Down. Okay, what about the minus sign? It's going to be, okay, so what's the math term? It's a reflection around the x-axis. Excellent. So my first point is at negative 4 and negative 6 here. Okay, and whereas before it would have gone up like this, now it's going to go down. So what does that mean? if I move to the right 1 unit, where am I going to go vertically? Down 1 unit. And if I move to the right 4 units, where am I going to go vertically? Down 2. Yeah, I'll come back to it. And if I move to the right 1, 2, 3, 4, 9 units, I go down how many? 3. So you see how that looks. Okay, so for part C, what's the domain? Right, and the range? Okay, so what's the domain here? Greater than or equal to -4? Less than or equal to -6. Okay, again, could I have figured this out for D from the equation? Well, yeah, because it's negative, it's going to be going downwards, so I got to go downwards. Okay, so this, right, you already know, right? You know what a horizontal how you get a horizontal translation. You know how you get a vertical translation. Do you see how it's the same no matter what type of equation you're graphing, right? And here, if this number is greater than 1, then it's stretched vertically. And if it's between 0 and 1, then it's compressed vertically, right? Just like we just saw. Okay. Moving on to inequalities then. Okay? All right. So how do I graph this? Well, I'm going to graph it the same exact way. Okay? Except, all right. So here, we're going to take this, set it equal to 0, x is equal to 1/2, so the horizontal shift is at 1/2. Okay? All right, so let's pick some points for this one, right? What point can I pick for x so I get a square root so I get a perfect square in the denominator? I mean, in there. Okay. Huh? So when x is 1, how much is that? It's 2 minus 1. No, when x is 1 and I plug it into the square root, it's 1. When x is 1, it's 2 minus 1. It's root 1. Okay, what else can I put in there? If I put 2, I get the square root of 3. If I put 3, I get the square root of 5. What if I put in 4? Right? What if what else can I do? 5, right? So when x is 5, I get 2 times 5 minus 1, that's 3. Because I want to get plottable points. I don't want to get like x equals 2 and y equals the square root of y equals an irrational number. Right. Okay. So, okay, now, this is, right, but that's off the grid. So now, this, however, is an inequality, right? It's greater than, not greater than or equal to. So when I do this, do I do a dotted or a solid line? I do a dotted line. Now, if I want y to be greater than, am I going to shade above or below? Above. But here's how you do it. This cannot even exist to the left of x equals 1/2, right? So it starts right here at the 1/2, and it's all of these here. Yes. Right, so it's just over its domain. Now, one other thing, when it's greater than, because it can never be, because the whole thing is dotted, when it's greater than, not greater than or equal to, that initial point there can't be a dot. It has to be an open circle.
Oh, yeah.
Right? Because that entire thing has to be dotted. All right, so let's do one more. Where does the +2 move the graph? Left and down 4, so left 2 and down 4 right there. And there is a minus in front, so if I go over 1, how much am I going down? 1. And if I go over 4, down 2. And if I go over 9,
No, you only do that because if you have like a 2x.
okay. So I started at -2. If I go over 4, I'm at x equals 2. When I plug x equals 2 in there, yeah, okay. So now it's less than or equal to. That means everything is solid.
So you're only picking points when there's a number in front of the variable.
When it's, yeah, and here. So I'm gonna graph the bottom here, shade the bottom part. Okay? All right. So to do it on the calculator, let's take out our calculators. All right, so I'm going to put in the first one. Let's clear this. I'm going to put in the square root of 2x minus 1. No. In order for it to shade above, right, because that's what you want it to do, bring the cursor, so by pressing the left arrow, bring the cursor all the way to the edge. Now, that's sort of like a toggle. You have to keep pressing enter, and it runs you through all of the different options. You want to pick the option that shows you shading above. That's shading above, right? That little icon there. Now, zoom 6, because I don't know where my windows were before, and there you have it. Okay? Amazing, yes? Yeah. Right, you need to do the dotting. So now when you press trace, okay, just exploring our calculators, at x equals 0, there is no y value. In trace mode, let me type in 0.5 for x. Just type in 0.5, press enter, gives you the value. Okay? Still they're not pressing anything different. I type in 6. What if x is 6? It's that. What if x is 5? Enter. It's that. Okay? Okay. So let's do the other one. Let's do the next one. For the next one, I have negative square root of x plus 2. Let's exit the square root, minus 4. This time, however, I want to shade the bottom. So here I am, right? So let's see what options we have here. When you press enter once, it's a bold line. This one is shading above. This one is shading below. That's the one I want. Let's see what else there is here. This one is like a series of points, a series of like, little bullet circles. You've got another one here that is not connected. You've got a dashed line, right? But you can't choose two options. Okay, so this is what I'm choosing now. Let's graph. There we go. Okay. Now, this homework will be due Monday. It must be done on graph paper, and they have to be professional looking graphs. All right?